Good evening, good afternoon, good morning. My name is Rolf Frischknecht. I will tell you about some insights on the Annex 72 on assessing life cycle related environmental impacts caused by buildings. I will share some insights of the current work. I cannot show you all of the results, but I hope this is of interest for you. This is not the graph that we anticipate for the COVID-19 infection rates, but this is the trend that we should aim at in relation to the net CO2 emissions, global net CO2 emissions, which ask for about net zero by the mid of this century. So net zero emissions means not only net zero emissions for cars or food, but also for buildings. And why for buildings? If we look at the UN Environment and IEA report 2018, we see that about 40% of CO2 emissions in the world are caused by buildings, either directly by firing or by burning fossil fuels, indirectly by using electricity that is produced with fossil power stations, or by using or indirectly by construction materials, the so-called embodied impacts, the embodied greenhouse gas emissions. So buildings is a domain which is relevant in terms of the contribution to climate change, and of course one of the important players when it comes to the reduction of the greenhouse gas emissions. The IEA Annex 72 takes the full scope of environmental assessment of buildings. So it covers not just the operational energy and water use of buildings, but it extends this to the maintenance, repair, and replacement during the use of the building. It also includes the construction efforts that are needed to erect the building and the production of the construction materials like cement, steel, or copper that are then used in the building. And it stretches out to the end of life stage of the building. So it also includes the waste treatment, the dismantling of the building, and the waste treatment of the building materials at their end of life. In that sense, it covers embodied impacts and operational impacts, and in that sense, the whole building life cycle. And this whole building life cycle has the requirement to get to net zero carbon emissions to comply with the Paris Agreement. The Annex 72 is subdivided in 5 subtasks. One subtask is about methodology guidelines, how to assess the environmental impact of buildings on a life cycle basis. Subtask 2 is about building assessment workflows and tools that are available to quantify the environmental impacts of buildings on a life cycle basis, and it includes building information modeling, BIM, related tools as well. One subtask is on case studies which serve either methodology guidelines, workflows and tools, but also LCA databases, building sector LCA databases, which is another subtask. And then we have the subtask 5 on dissemination. I will now go and show you some of the results from some of the subtasks. We had one of the papers that has been released early this year, and which is one of the most cited papers in applied energy. We investigated several hundred published papers on the embodied and operational carbon emissions of buildings, and we sampled them into residential and office buildings, and we checked how big is the carbon footprint of the embodied part of construction of a building, and how big are the operational carbon emissions. We grouped the buildings into 3 groups into buildings according to existing standards, to new standards, and to new advanced standards. And what we can observe, if you see on the left-hand side, you see the greenhouse gas emissions in kilogram CO2 equivalents per square meter and year. And on the right-hand axis, you see the share of embodied greenhouse gas emissions in percentage. And the dotted line tells us that the share of embodied impacts is increasing from buildings according to existing standards to the new advanced buildings, so the buildings that are under construction today. And it reaches nearly 50%, between 40 and 50% in these new advanced buildings. This is, on one hand, mainly due to a strong decrease of the operational carbon emissions, as we can see for the office building, but also for the residential buildings on one hand. But on the other hand, we also see that embodied impacts do not decrease, but especially in the residential buildings, they even increase from existing standards to new advanced standards. This tells us that embodied greenhouse gas emissions get more and more important and should be addressed in current building assessments or in current construction. We then compared the embodied greenhouse gas emissions on the x-axis and the life cycle greenhouse gas emissions on the y-axis, and compared them to existing benchmarks like the Swiss Engineers and Architects benchmarks 2040, which is shown by the dotted lines. And we can see, here we see with the crosses the existing standards, the circles show the new advanced standards, and the triangles indicate new standards. We see that in each group of buildings, so independent of the standards, there are some buildings that comply with this rather strict benchmark of CO2 emissions per square meter and year. But we also see that there's a large universe of buildings that today are beyond the benchmarks or the emission level that we should strive for when we want to move towards the 1.5 degrees Celsius scenario. On this graph, we see the building greenhouse gas emissions of buildings, how they evolve over the years during the lifetime of a building. We see in orange the embodied greenhouse gas emissions, which start with an initial emission when constructing the building, manufacturing the building materials and construct the building. Then there will hardly be any additional emissions until we have to replace, for instance, the windows, which give another spike here as an increase in the emissions, and then it's stable again. On the other hand, we have the in blue, the operational greenhouse gas emissions, which are linearly increasing over the years if we follow a static approach. This is the upper line, or they may evolve with a slope that is getting lower if we look at the dynamic approach, in which we assume that the electricity mix that is feeding or that is used in the building gets lower carbon intensive, or gets a lower carbon intensity with time. This is for the new standard building. If we go for the new advanced building, we have a larger spike at the beginning, but at the same time we have lower operational energy demand, and let's say the break even when the operational impacts, the operational greenhouse gas emissions equal the emissions from the embodied part is later in the lifetime of the building. Here we have it at about 10 years. In the new advanced building, it's about 35 years, up to 50 years if we use the dynamic approach. We also discussed a typology of net zero building approaches, and this has also been published in a paper in the new journal Buildings and Cities. authored by Thomas Lützgendorf and myself, where we provide some definitions of how net zero emission buildings can be defined. There's a net balance approach where the potentially avoided emissions due to production of electricity on site in the building with photovoltaics, which is then exported to the grid, may cause some reduced emissions outside the system boundary, say in the grid. This might be used to call a building a net zero emission building. Economic compensation is another measure to reach net zero emission buildings, in that the owner of the building purchases CO2 certificates to cover the life cycle greenhouse gas emissions that are caused by the building. The next more ambitious level is investment, is not just buying certificates, but investing in technical reduction measures like negative emission technologies, like the extraction of CO2 from the atmosphere and the long-term storage underground. And the real zero emission buildings, they use construction materials and operational energy with zero greenhouse gas emissions, which include the supply chain emissions, of course. You can imagine that the emission level increases from left to right. We don't have currently construction materials with real zero emission levels, so we should focus on these measures like technical reduction or economic compensation to reach net zero buildings. This net zero definition may be applied on different levels of the building life cycle. It could be applied on the direct emissions during operation of the buildings. This is mainly achieved by using renewable energies or by using electricity, so then you don't have direct emissions, direct CO2 emissions at the building. If you want to be a bit more ambitious, you can include the direct emissions from an operational energy demand, but also the energy supply chain emissions indicated by this one. And then, of course, you would have the CO2 emissions from electricity generation in your accounting. And the most ambitious level would be to cover the full life cycle of the building, so including production of the building materials, construction, maintenance and repair, as well as end-of-life treatment of the building in total. We also checked with the different countries in the course of the planning process of a building, starting from strategic definitions of how a building could look like to preliminary study, concept design, developed design, and so on, up to the end, where in the process environmental performance targets are being defined and where, for instance, the building permit is being given. And we see that performance targets are defined in Canada rather early at the preliminary study, even earlier in France and Sweden. And Sweden has also even 3 levels or 3 stages in the planning process where performance targets are being defined and assessed. So this helps us to identify the right places where environmental life cycle assessment is being used in the planning process. We also did a survey. Our partners from Korea did a survey on LCA databases that are being used in the different regions of the world. And we can observe that life cycle assessment databases are in use since decades, even as we can see here in Asia. In Japan, we have 10 years time record. In Korea, it's even more than 20 years of experience with using life cycle inventory data. So this situation can be observed in Europe and partly also in the Americas as well, that there's a long tradition in establishing and maintaining life cycle inventory databases, which are one of the core bases to perform life cycle assessments of buildings. What we observed during the different assessments that we did, or the national assessments that we did on identical buildings, is that the results might differ, but they are mainly used in a national context. And so we propose to use a package of 4 elements for national buildings LCA. And the package consists of a method which covers or which defines which life cycle stages to include, which building elements to include, how to cover operational energy, how to deal with allocation issues, and so on, which can be a national method, which consists of a background data like a life cycle inventory database, which should be one defined database on a country level, including a defined version. Then a set of benchmark values which may be different for different building types and which may differ from between new and refurbished buildings, but which rely on the background data of the country and the methodology that is applied in the country. And the 4th element are accredited tools, design tools that are based on the designated method in the country and the background data that is being used in the country, and which is successfully verified. So it has been tested that it provides, that it uses the right data, the correct data, and implements the method in an appropriate way. I come to my last slide. The embodied environmental impacts gain importance, as we have seen in our meta-analysis of buildings LCA papers. So they need attention, and they need more attention as they had in the past. And the Paris Agreement calls for high ambition net zero emission buildings. It does not only do so for buildings, but for other goods and services as well, but it also calls it for the buildings. And we consider guidelines, data, and tools being ready for application in many of the countries, and it is now the time for life cycle-based policy measures in the different countries. So thank you very much. This is, and I'd like to acknowledge all the experts from the different teams. This was our last meeting in fall 19 in Ljubljana. Thank you very much for your attention.